we need to talk about the solar system. Solar system. First of all, I just want to very quickly review, okay, there's a difference between solar system and galaxy and universe, and sometimes people get these confused a little bit. So there's solar system, there's galaxy, and there's universe. Our solar system is the sun and everything that orbits around it. So it consists of the sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, still Pluto, it's still there, comets, asteroids, the moons around the planets, rings, all that sort of thing. That's what our solar system is, the sun and everything that orbits around it. Our galaxy, well, let's see, our sun, our solar system contains one star, the sun. Our galaxy contains several hundred billion stars. So our galaxy is the Milky Way. Milky Way. It contains hundreds of billions of suns, of stars. Sun is a star. An example of a star is our sun. So the solar system is the sun and all that orbits it. And the universe is everything. So we live in the Milky Way galaxy. It contains hundreds of billions of stars. We find out that there are many other galaxies out there, hundreds of billions of them at least, and everything that exists. All galaxies, all stars, everything everywhere, that's the universe. Okay, so just so we're clear on those terms, now let's go back to the solar system. What's the most important thing to know about our solar system? If we study our solar system, what is it? Okay, it's the sun and everything that orbits around it. Well, what is it made of? If you were to add up the mass of everything in the solar system, I love at this point in class I say now, which do you think would be more masses? If you added up on one pile all the planets in the solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, throw Pluto in, throw the comets in, the asteroids, everything in our solar system, the moons, the rings, you put all of that together in one pile, and then on the other pile you have the sun. And I say, now which one would weigh more? Which has more mass? The sun or everything else in the solar system? And I have the class vote on that, and we find out that the sun wins. The sun has more mass. And I say, well, what percentage of our solar system's mass is the sun? If you weighed everything in our solar system, worked out the total mass, and it's more than 50%, it's more than half sun, well, what is it? 60%? 70%? Different people around the class bid on this. 80%, 90%, 95%. And the answer is our sun, by mass, our solar system is 99.8% sun. So everything in our whole solar system other than the sun, everything else is less than 0.2% by mass. So if you weighed everything in our solar system, you would find that everything else is less than 0.2%. Basically, the sun weighs, if you get the exact numbers, it weighs like about 700 times more mass than everything in the whole rest of the solar system combined. Our solar system is dominated by the sun. The sun is by far the most important thing in our solar system. Our solar system is the sun, and then a few minor details that are left over. The rest of the solar system are the crumbs when you make the sandwich of the sun. So the sun is the sandwich, and everything else, all the other planets, even the big ones like Jupiter and Saturn, I mean, these are big, massive planets, but they're nothing compared to the sun. Our solar system is dominated by the sun. All right, so that's the first thing we need to know. Now, moving on beyond that, what do we do? What's the scientific process? We observe the natural world around us, we look for patterns, and then we try to come up with theories and hypotheses to explain these patterns. So let's start looking for patterns. And the first pattern we see is that there's a colossal, amazing, extraordinary pattern in the motion of things within our solar system. Basically, everything's going the same direction. So the planets, so we're looking for patterns, and this one we're going to find is a pattern of motion. So the planets all orbit the sun in the same direction. They orbit in a fairly flat disk, and they're all orbiting in the same direction. So if you're above the Earth's if you fly away from the Earth up above the North Pole, you would see everything orbiting around the sun counterclockwise. Planets all orbit counterclockwise. If you went from the South Pole, they would all orbit clockwise, but we're in the Northern Hemisphere, so we're going to go clockwise. And so the planets all orbit, almost all the moons orbit around their planets counterclockwise. Moons orbit counterclockwise. In addition to that, almost all the planets and moons rotate, spin. You know, like the Earth orbits once every year, the Earth spins, it rotates once every day. And most all planets and moons spin counterclockwise. Comets, asteroids, the small fry, these little junk sorts of things in our solar system, they basically all go around counterclockwise. Comets and moons, they orbit the sun counterclockwise. The rings around the planets tend to go counterclockwise. In terms of the rotation, I guess the exceptions are Venus rotates backwards. It still orbits the sun counterclockwise, but it spins backwards very slowly. It spins clockwise, and then Uranus is tipped on its side, so it's like, well, so it's not. And then the sun itself, the sun rotates counterclockwise. That was discovered by Galileo. He pointed his telescope up at the sun. He saw sunspots, and then he saw, the sunspots are tracking around the sun. And then they appear on this side and go around that side. The sun spins around roughly once every month or so. The sun makes one spinning sort of thing. So the amount of time it takes the moon to orbit around the Earth and the amount it takes the sun itself to spin are similar. Total coincidence, but they are. And so everything goes the same direction. So this is a colossal pattern. Almost everything in the whole solar system both orbits and spins in exactly the same direction. They're all going in a flat disk. They're all going counterclockwise. And so then the question is why? So this is the observed pattern. It's a colossal pattern in motion. Almost everything, with a handful of exceptions. Of the hundreds of moons in our solar system, there's a handful that go the wrong way and stuff like that. But overall, there's this amazing colossal pattern. Almost everything in the solar system both spins and orbits in the same direction, counterclockwise. And so the question is why? Why would that happen? That can't be a coincidence. It's not just happenstance that everything just happened to orbit and all that and that sort of thing. So then we ask, so there is the observation. So patterns in motion, so we have this observed pattern. And so now that we have an observed pattern, now we need to understand why. So we need to come up with a theory. We need to propose a hypothesis. So now it has been well tested. So then now we need a theory to explain this. Well, first of all, the reason why they're going around, the counterclockwise spinning and orbiting counterclockwise today is because they did that yesterday. Once they're going to keep going. And they would have done that the year before that and the year before that. And let's remember, this is not coming out of Newton's laws. According to Newton's laws say that all orbits must be in the form of ellipses. But they don't say which way. They don't have to orbit in a flat disk. Basically, all the orbits of the planets are circles, too. But according to Newton's laws, they could orbit in ellipses in every single direction. They don't have to be in a flat disk. They could orbit any which way they want. Gravity between the planets would not pull them into this. That's not to do it. The fact that the sun is spinning has nothing to do with its gravity. If you were to stop the sun's rotation, a giant hand from space reaches in, grabs the sun, stops the sun from spinning around once every month or so, the planets would keep orbiting in the exact same way. The spinning has nothing to do with gravity. So no, this is a real issue. It's not like Newton's laws make things all orbit in circles. No, it can be any kind of crazy ellipses or hyperbolas or parabolas, but they can orbit in any direction at all. Newton would allow anything at all, as long as it's an ellipse in some sort of crazy cattywampus direction. But instead we see that they're well organized. The orbits are very close to circles. They're all going the same direction. Why is that? And so we need a theory to explain that. Well, they're doing it today because they did it yesterday and the day before that and 100 years ago and 1,000 years ago and a billion years ago. You were to come at the solar system, you would see the same pattern of motion. So this must be telling something about how things got started. So theory to explain a pattern of counterclockwise motion quickly takes us back to the idea that, this must have to do with the formation of our solar system. This must be telling us something about where our solar system came from. So the first thing we recognize is, since they all share the same motion, that must be telling us that all the objects in our solar system formed together at one time in the same way. So theory to explain, the first bit is the whole solar system formed together at one time, in one way, in one process, one event. One event that took place is how our solar system formed. So this is interesting. Now we have a theory that says, okay, so that things form together at one time, at one event. So that's, I mean, if they formed at different times in different processes, I would expect them to have all different motions, but because they all share the same motion, because they all share this same well-organized counterclockwise motion in circles around the sun and spinning and all this sort of thing, it means that it couldn't be just a coincidence. So it means they must have all formed together at one time as part of one event. So that's a huge sort of thing like that. Whole solar system formed together at one time, one event. And so how did it form? Well, if we've got all these individual little objects doing this and they share the same motion, they must have all been initially part of the same object. Formed. So what makes sense? How could this happen? We know the laws of physics, we know the laws of motion, all this sort of thing. So what would make sense? Well, if you had one object which was all moving around together, one big spinning sort of thing, and then it fragments and it breaks into pieces. And most of the stuff goes into the center to make the sun, and then all the little bits and pieces share some of that motion left over. Formed from, so what would make sense? One, well, we know what the sun is. The sun is a big cloud, big gas and mostly gas. The sun is 70% hydrogen, 28% helium, 2% everything else. So that must have been what this initial object mostly was. From one big cloud, the word is nebula of gas and dust too. You gotta have some solid sort of stuff if you're gonna make the Earth. So there must have been one big cloud, nebula of gas and dust that was spinning. And then this must have broken apart into pieces. And why would it broken apart? Gravity will break it into part. If you got a big, well, we understand gravity. If you got a big thing spinning in pieces, well, gravity is going to pull a lot of stuff into the center. When you run the math actually works. Yeah, it's a big cloud of gas and dust. Sure, 99.8% whatever is going to end up in the center. Just, gravity's going to do that. And then what's going to happen to the rest is, well, it's the bits and pieces are going to stick together. Gravity will tend to gather things. And since they were all, since you have one big spinning cloud of gas and dust that's all spinning together, then every piece is going to get sort of that. It's like if I had a bicycle wheel spinning, imagine I had a bicycle wheel spinning right here, and then I take a hand grenade, and I pull out the pin of the hand grenade, and then I run over there, and the bicycle wheel's spinning, it's got the hand grenade on it, and the hand grenade explodes and shreds the bicycle wheel, and all the fragments of the bicycle wheel go flying off in all directions. And if you took pictures of that with a high-speed camera, you would see that every single one of those fragments has some of that initial spin. Spin is something that once you have, it can't go anywhere, you can't create it or destroy it. So every single bit of that bicycle with all the pieces of rubber and metal and all this would all be spinning in exactly the same way. If it was initially counterclockwise, they would all be spinning counterclockwise. And so that makes sense. Except that in this case, for this spinning, the nebular theory of the formation of our solar system, you got a spinning cloud of gas and dust, and it implodes, and gravity pulls it together, and all the little bits and pieces form this. And so now we have a theory to explain it. The theory explains the pattern, and then I say, well, what's the evidence for this theory? The evidence is the observed pattern. There's this relationship back and forth between observed pattern, which is observational evidence, and theory. The theory explains the pattern is evidence for the theory, and so these relate to each other. And so now, so that's one of the big ideas to understand in what our solar system is and where it came from.